Google just released Gemini 3, and it's one of the most significant updates we've seen this year. Now, expectations were high going into the launch, and early benchmark shows that the performance gains are real. And in this video, I want to give you a practical look at what the model can actually do. And because I respect your time, I will highlight the key topics that we'll go through so you can skip ahead if you want. First, we'll build a space simulation with toggle controls. Then we'll prototype a small tower defense game to test how it handles more complex logic. And finally, we'll go through a set of key architectural points that are good to be aware of, and also cover Gemini 3 specific prompting techniques, so that you can get the most out of the model. If we haven't met before, I'm Ali Salem, and I currently work as a director in a tech company. And on this channel, I'll help you turn tech and finance into your personal advantage. One of the key areas where Gemini 3 stands out is simulations. And it's not because it's flashy, although it is pretty flashy, but because it can actually reason about systems, plan out logic, and then implement everything in a single coherent workflow, which is actually really useful. Now, to show what that actually looks like in practice, we're going to build out a small space debris simulation live inside Gemini. Now, there are multiple ways that you can access Gemini 3. I'm going to show you one of the ways here, and that is through the Gemini app. And when you're in this view, you can just click the model selector here, and you can choose between either a fast model or thinking with 3 Pro. So this will actually use the new Gemini 3 Pro. Another way is, of course, to use Google AI Studio. I decided to go with the Gemini the app. It doesn't really matter which one you go with, but I'll use the app for this one. So let's drop in our prompt. And actually, I'll fire this away, and then I can take you through the prompt itself as it's building out the app. Or the simulation, rather, sorry. And it's not necessarily because it takes super long. In fact, it'll probably be done before we have gone through the prompt. Okay, so we start off with the task. This is basically the headline. It's one sentence describing what to build. From there, you have the core requirements, and this is essentially a visual checklist. Think of it as the minimum visual fidelity you want guaranteed. After that, you have the simulation section. This defines the rules of the world, the orbital paths, camera behavior, speed, and how collisions are detected and escalated. If the model is the engine, then this is the physics layer. And we can see that the simulation is actually completed, but let's just finish off the prompt before jumping into the simulation. Next, we have the interaction UI. This is the user interface, the toggles and sliders, everything the user should be able to manipulate as you're interacting with the simulation. Following that, we have the technical section, which is essentially the trade-offs. So in this case, we want to prioritize performance, keep geometry light, avoid complex shaders, and don't generate anything that would break the runtime. And lastly, we're essentially telling Gemini to run the simulation directly inside the chat without kind of dumping a bunch of files for you, which you can also ask for if you want that. So first, we can kind of zoom in and out and scroll around the whole area. We can see the satellites here roaming the outer rims of the atmosphere. We also have the option to follow a satellite. So if I toggle that on, it will actually follow one of the satellites as it's going on its trajectory. And then we can, of course, trigger a bunch of collisions in here. So we can do that by bumping up the timescale, so now everything moves faster. And then if we increase the debris count, all right, that's a lot of space dirt. And let's adjust the collision sensitivity. Now, I assume that all the red dots that we can see around here are indeed collisions. Not entirely sure. And that leads me to one of the cool capabilities in here. Because you have the simulation and we have canvas turned on, it essentially means that we can start adding additional capabilities within this simulation. So let's do like this. Let's say that we want to add the following enhancements. 1, every collision should cause an explosion. Second, satellites should have a small chance to collide with debris and explode. Third, add the capability to launch additional satellites. And this is what's pretty cool about it, that you can enhance your simulation as you go. Now, a good best practice when you're building out apps or simulation is actually to add one adjuster at a time. So I just added 3 of them. That is not best practice, because if one of them breaks, then you kind of have to reset all 3. Whereas if you go one by one, then you can also always jump one version back, which makes things a lot easier. All right, here goes. I can already see some of the explosions happening here. Let's follow one of the satellites and see how often it collides with the debris. So I just noticed that the moment I increased the timescale and the debris count, it only took a couple of collisions for all the satellites to crash and burn, which went faster than I thought. So let's try launching some new satellites and see how long does it actually stick around before it breaks. Either this is a heroic satellite or the other ones had garbage production, because they disappeared very fast, and this one is sticking around. Okay, let's increase the collision sensitivity just to see how it disappears. Okay, there we go. So obviously this is pretty cool. I do want to show you a couple of additional cool things that you can do in here. If you, for example, want Gemini to add suggested features, you have this little button down there that says Add Gemini Features. And if you click it, it will kind of fire off its own prompt, and we'll see what it's going to do. So it looks like it will enhance the simulation with AI-powered mission control features using the Gemini API. So okay, we'll see how that works. I don't think that it's going to work very well. And this is a learning, by the way. If you want to use the API, you kind of need to connect the API key in the background. Otherwise, you will likely get an error message, but we'll see what happens here. Okay, so it looks like it has some commentary at the bottom here, and it now has this analyze status, which I assume will use the Gemini API. So let's try firing it away. There we go. So it says AI module offline, no API key. If you want to use these more advanced features where you're basically connecting your app to the LLM, so you have more of a kind of interactive or generative feature within the application that you're building, or simulation for that matter, then that's all good. You can just connect up your API key. It's a little bit out of scope for this video, but there should be a bunch of videos showing you how to do this, but let me know if that is not the case, and I can create a video where I can take you through how to set up an API key. Now, the last thing I just wanted to show you is that you have an ability to kind of snapshot something on the screen and then ask for an adjustment on that specific thing that you have snapshotted. So the way you do it is by clicking the snapshot button and then highlighting the element. Hold on, let me just do it like this so it doesn't actually break. So let's reduce the time scale. And now let's highlight the satellite and say, can you give each satellite a name? The name should be displayed below the satellite. All right, here we go. Sat beta, let's click again, sat gamma, sat epsilon. So that's pretty cool, right? Now, this is obviously a really cool feature that you can build up simulations like this. Kind of close to an MVP, right? A minimum viable product. We just dumped a bunch of ideas into this and started playing around with it. What you can also do is just pick up the whole code set. So if you click code, you'll see every line of code that Gemini generated in order to build up our simulation. If you just click anywhere, you can click Control A, it will mark everything up, and now you can just copy it. If you then drop this into a notepad and you paste it in here, now all you need to do is denote this as space debris sim. You can call it whatever you want, but the important part is that you end it with .html, because that text file is now saved as an HTML document, meaning that if you double click this and you pop it open with Chrome, you now have the ability to actually have this as if it was an actual web page. So this is the same simulation. You have all the toggles here. You can launch additional satellites, etc. But more importantly, you now have the whole set of code that built up the simulation. So if you now want to take this text and drop it into a different tool to enhance it further, like Claude Code, or maybe you want to enhance it with Codex and ChatGPT, then you can do that. And of course, you can just continue enhancing it here as well. But like this, you have it stored as a file and you're no longer restricted to using Gemini for it. But really, in order to turn this into something more tangible, you would need to do the same thing as we did here, which is basically to induce more deterministic rules. So if you want a very specific type of collision percentage that increase every time you adjust the units on the slider, for example, then those are the rules that you would need to add in here, be it inside Google or if you want to use a different tool because you find it easier to add deterministic rules in there. It's whatever floats your boat, but at least now you have the ability to kind of move things around as you need if you want to use it for something more than just a flashy prompt like I did. Quick pause, I have a favor to ask. If you're enjoying the video so far, you should consider becoming a part of the small, but very exclusive group of around 5% of viewers that have subscribed. And if you've already subscribed, I just want to say thank you. You're the reason why this channel keeps growing and keeps getting better. Another great use case for Gemini is building apps. And if you go into Google AI Studio and click Build, you'll see a bunch of really cool apps that are available for you to try. And you could really see that it pushes the boundary of what you can do in Gemini when you're building out the app. So I think the coolest one I saw was probably this one, where you basically hold up your fingers and the webcam is going to recognize your fingers as two lightsabers. You have to kind of hit the stars and the corresponding color. So you can do some pretty advanced stuff. And I did want to show this to you because you can actually go in here later and try out some of these apps, get some inspiration, and incorporate the elements that you like into the app that you're building. We're not going to be trying out the existing apps. We're going to build our own from scratch. But I did want to highlight that you should go in here and check out what they have pre-built for you, because it is actually really cool. Now, the app that we are going to build is a tower defense game. You may or may not see the timer at the bottom. It's pretty late where I am. It's because I'm in a bit of a crunch at work. So what's keeping me running right now is my friend over here. And you know that I'm crazy about coffee. So we're going to make a coffee themed tower defense game. And this time, let's actually just go quickly through the prompt before I fire it off. So in short, what we have here is build a small but fully playable 3D tower defense game themed around coffee. The task section again just outlines the objective. The game theme is the skin on top. It defines the coffee mugs as towers, beans as enemies, and the basic 3D map concept. And then we have the game rules, which is essentially the logic of the game, how waves works, how towers behave, how enemies move, and how you actually win or lose. And then we have the interaction UI, which describes how the player interacts with the game. It's the buttons, the overlays, how you place the tower, starts the wave, etc. It's kind of the same function as we had when we built out the simulation earlier. And then we have the visual style. And the key thing here is essentially that we want to keep the graphics simple and readable, so the model doesn't waste effort on things like fancy shaders instead of gameplay, right? And technical constraints sets the guardrails. Keep it performant, single file, no external assets, and cleanly structured code. So this is basically an additional layer that guardrails the performance. And lastly, we have the runtime behavior that essentially tells Gemini to run the game in the chat rather than dropping us the HTML file that I showed you how to build out at the end. So with that said, let's fire it away. And just to be clear, you don't need to use Gemini to build simulations or games. You can use it for anything that you would normally use like ChatGPT for. It's just these two use cases are so exceptionally impressive when it comes to Gemini that I decided to focus in on them. But it's a multimodal model, so you can use this in your AI model of choice that you would normally use for everyday tasks. All right, here we go. I have to tell you something funny. I think I ran this prompt about 5 or 6 times just to cross-check that it would work when I showed it here in the video. And every single time I ran it, it gave me a new version. So I honestly don't know if this is gonna be good or bad. There has been quite a bit of variance. But at the end of it, you kind of just have to prompt chain and push it into the state that you want it to be in. But let's see how far we get on that first prompt. So we can see that we have our 3 towers at the bottom. Let's drop a latte. Actually, let me just see. Let's drop a latte. Can we drop a latte? Okay, I mean, fair enough. It seems to work. So honestly, it's not the best generation of the game that I've seen when I tried it, but it does the trick, right? Now let's do what you would need to do a couple of times before you should consider yourself happy with this, and that is to add some additional iteration enhancements. And again, you have canvas turned on here, meaning that you can add your incremental adjustments to it. So let's do like this. Add the following enhancements. Again, I'm gonna add multiple ones, even though that is not best practice, but I do want to respect your time. It would take a little bit too long if I were to do this in 5 separate prompts or whatever we're gonna do here. So first, add sound. Let's add some sound in there and see what happens. And secondly, let's do like this. Enemies start in a roastery. Let's call that the spawn. And finish at an espresso machine, which is the base. All right, let's see how this actually looks. So the controls are a little bit painful to deal with. It doesn't seem like I can remove the centeredness around the map and the free roam. But over here, this piece down here is the roastery. And the white piece down here, which really doesn't look like an espresso machine at all. That's supposed to be the espresso machine. So nevertheless, let's see if it actually works here. Yeah, why not? That's some cute Super Mario sounds. Okay, let's do one last enhancement. So add the following 2 enhancements. First, towers should hover above the tile before placement to indicate position. 2, add smoke coming out of the roastery's chimney. because that's important, right? We want the coziness effect. All right, there we go. And the smoke is actually coming out of the roastery. Looks pretty good. Now let's see if the towers are actually hovering when you're about to place them. Yeah, there we go. I still think there are some improvements to be made in terms of highlighting the tile, but it's definitely better than not knowing where it's going to drop at all, which is kind of how it was in the previous version. So let's try a different tactic. Let's just spam espresso. Okay, so I'll put this on mute and then we can let it run as we're talking. The key takeaway from all of this is that it's really your creativity that sets the limit here. Is this a super impressive game that is going to be a top seller? No, it's not. But what you can see is that when you do these smaller iterative enhancements, you can induce the change that you wish to see in a fairly simple manner. So we asked it for the smoke in the chimney, it did that, no problems. We asked it to highlight the cups, it did that. When it added the roastery and espresso machine, it did that as well, but you know, I was not very impressed with this espresso machine that looks more like a refrigerator. But nevertheless, we did all of this change in 2 iteration enhancements. Imagine what you can do if you do like 10 or 20. You can make something really cool. In terms of the mindset of what you should aim for when you are either in the Gemini app like I am right now, or if you're in Google AI Studio, you should aim for an MVP. You should not aim for a production ready app because it's really hard to do using the capabilities that you have in here. Google AI Studio and Gemini is for prototyping. So it's basically to put together a core concept or a skeleton of what you're trying to achieve, and then have some quick iteration enhancements as we have here to try and figure out whether something works and get the feeling for the product that you're trying to produce. And then from there, you can add the additional layers of sophistications on top of it. You can either do that within the Google ecosystem, or you can do it outside of the Google ecosystem. But if you try to aim for perfection using the Gemini app or Google AI Studio, I think you're just going to be frustrated. It's not what it's for. I just want to get that said so I don't oversell this. You can absolutely generate a super solid starting point. If you have that as your end goal in Gemini and Google AI Studio, you're going to be gold. Just have a plan for what you do after. I know a lot of you have the ambitions of deploying something that you can earn money on, and this would absolutely be a great first step for you to do that. So Gemini is a multimodal reasoning model, meaning that it can natively consume different types of input, such as text, sound, code, images, or video, and then also apply deep reasoning to complex tasks. And a big part of how it does this is through something called mixture of experts. And this is really the engine for reasoning. It's what allows models like Gemini to scale their total knowledge capacity into trillions of parameters, which basically is the prerequisite for advanced reasoning. And within that system, you have a collection of specialized experts. So when you submit a complex problem, the router doesn't light up the whole network. Instead, it selects the most relevant experts for each token. So if, for example, the task involves logic and math, it might activate those specialists. If it involves visual structure or long-form reasoning, it activates those experts instead. And this targeted activation means that the model can lean into the right skills at the right time and do so efficiently. And on top of that, Gemini has a huge context window of 1 million tokens. And in one of my previous videos where I covered Google AI Studio, I calculated that 1 million tokens roughly equate to 8 average length English literature books, which is really impressive, right? But just because you can load that much context doesn't mean that it's the right thing to do. Which brings me to the Gemini 3 specific prompt engineering guidance that I wanted to take you through. Because Gemini 3 is a reasoning model, and that changes how you should prompt. So here on the screen you can see the prompting best practices for Gemini 3. And it basically says that Gemini 3 responds best to direct, clear instructions. And this is an important one. It may overanalyze verbose or overly complex prompt engineering techniques used for older models. So I like to think of this as like general multimodal models, like GPT-5, can be viewed as a junior colleague. So the general rule of thumb is kind of the more context, the better, right? Same way as you would over-contextualize things for a junior colleague that starts at work. However, reasoning models like O3 or O4 Mini or Gemini 3 are more like senior colleagues. Here you need to focus more on what needs to be done and less on how it's done. Same way as you would have with a senior colleague, right? Okay, moving on to the next point, the output verbosity. It's basically stating that Gemini 3 is less verbose by default, which means that it provides more direct and efficient answers. I love this. In fact, I tend to instruct the models that I prompt in to do this. Now, the key takeaway though is that you need to prompt it based on what you need. So if you want a more chatty persona, you should say that, or whatever tone you want to steer the model into, you need to be explicit about it. So if you're looking for a more comprehensive response, make sure to say that. If you want it to be more brief or direct than what it currently is, then state that as well. And lastly is context management. And the key point here is that if you drop a large data set, then you should state the ask or the task at the end of the prompt after the data context. So it basically says, anchor the model's reasoning to the provided data by starting your question with a phrase like, based on the information above. Now, this is different from what a lot of other prompt engineering guides are saying. You know that we, for example, always put the task at the top, or perhaps after the persona if we add that in. And context tends to come in the middle of the prompt. So this is good to be aware of. But again, to me, this comes back to the junior-senior analogy. With reasoning models, it's better to just get straight to the point. So I'm not surprised that we're heading this way. In fact, I think it's really convenient because it's kind of like, here's your data dump, give me X. You don't need to do all the additional engineering around your prompting. So if this is truly the way all the other models will be heading as well, I mean, I'm gonna be a really happy guy. And that's it. Now you've learned how to use Gemini 3, and you've also learned how it works. As always, let me know if you liked it, and let me know if you didn't like it, because this channel is for you. So your feedback really matters. In case you want to continue your learning path in the Google ecosystem, I will point you to this video over here that covers the latest advanced features in NotebookLM. So with that said, stay curious, stay caffeinated. Thank you for trusting me with your time, and I'll see you in the next one.